In this video, I'm going to teach you about the terms central and pendant atoms, as well as how to determine the steric number of a model. So notice I'm going to teach all of these things on the model, which I will have pictures of models on exams, but then you'll also apply it to Lewis structures. So keep that in mind. The central atom. So here I've given you a model of a molecule, and the central atom is the one that's in the center. The pendant atoms are the ones that are directly attached to the central atom. So central atom is the atom in the center, and pendant atoms are atoms that are covalently bonded to the central atom. So that's what this little line is representing. Pendant lone pairs, that's not really what anybody calls them, but I like to call them pendant lone pairs because they are attached to the central atom, also take up space. So it's really important to recognize what's directly attached to the central atom, because the more things I have attached, that's going to change the way these atoms are arranged in space. Okay, so the atomic shape, what it looks like in space, depends on how many electrons. Actually, let's say how many lone pairs. And this is one lone pair. Remember, a pair is two. So I have two right here, one lone pair. Or atoms directly attached to it. Electron-electron repulsion. So you know electrons repel each other. If I have an electron, you saw when they were filling orbitals, they would fill up p orbitals separately to be farther away from each other. Here, might as well draw on my third p orbital. I have three. Here, our electrons repel each other, and so they're going to be as far away from each other as they can. So electron-electron repulsion around the central atom occurs between lone pairs and other atoms. And just a reminder, let's say this green is chlorine. So for an example, this green ball could be chlorine. Chlorine has electrons, so it's not just a nucleus, it has also those electrons. So really what you have are the electrons repelling with other electrons. Also repelling each other are these two atoms. So chlorine, if this was green, was chlorine and chlorine, those two would be repelling each other. So atoms repelling with other atoms. And then of course, if I had two lone pairs want to distance themselves from other lone pairs. But of course, they are around the central atom. So they only have so much space that they can move around to avoid each other. What would you call this, central or pendant atom? Hopefully you said that's the central atom, and these are the pendant atoms. So let's keep on moving. There's this idea, it's a terrible name, valence shell. So the electrons on the outermost shell of your atom, electron pair repulsion. These valence electrons repulse each other, and they help us explain where the atoms and lone pairs are relative to each other, which dictates the shape of a molecule, and we can use that to predict bond angles. So the shape around a central atom is different, and it depends on what takes up space. You have an atom, what takes up space around that atom, other atoms, and other lone pairs. And lone pairs. And notice it says directly attached to the central atom. I could have a central atom and other things all the way the heck over here that wouldn't change the bonding around that atom. Okay, so these things, these atoms and lone pairs, are called the steric number. The steric number is the number of atoms and lone pairs directly attached to the central atom. So we're going to use that term a bunch. You're going to learn a lot of new terms today. So if you need to, pause and just kind of think about what that means so you can memorize them now, not later. Steric number is the number of lone pairs or atoms that are directly attached to the central atom. Okay, so steric number practice. Let's do the first one. My central atom is the one where, hopefully you said in the center, that's my central atom. How many things are attached to it? 1, 2, 3, 4. So 4 is my steric number for that. What's my steric number for this one? You'd say, okay, here's my central atom. 1, 2, 3, 4 things are attached, so it has a steric number of 4. Let's look at the next one. I have an atom. It has 1 group, 2 groups, 3 groups, 4 groups. So this steric number equals 4. You're starting to think, are there anything other than 4? Now let's do this one. So you have this atom, and it has this one attached, and this one directly attached. I have 1, 2 things attached on my central atom. So my steric number is 2. How about this one? My central atom's what color? Black, the one in the center. How many things do I have directly attached to it? I have 3. How about this one? Central atom's black. I have 1, 2, 3 things bonded to it. My steric number is 3. And the last one, 1, 2, 3 things directly attached to it. So the steric number equals 3. The steric number is pretty easy to figure out. You just need to remember the number of lone pairs and the number of atoms. And then remembering what the heck is steric number. Steric number is just the number of atoms and lone pairs directly attached. What is the steric number of this one? Hopefully you said 2. Has a steric number of 2. Now notice, when you look at this, you can already see that these molecules look different, right? I don't know if you can tell, but this one's flat, this one's flat, this one's flat. This one looks like it's a line. This one has a bunch of different things coming off of it, and those are dictated by the number of things that are attached. Okay, so we're going to talk more about that, but that is how you determine the steric number. Now, let's talk about how you actually, I'm going to do this one in the next video.